series and parallel pump apparatus. This apparatus is used to demonstrate the characteristics of a pump when the pumps are working in series, when the pumps are working in parallel, and also we are able to draw the characteristics curves as well as to find out the efficiency of a pump when operating single, in series or in parallel. If you see this apparatus consists of a control panel, consists of 3 rotary switches for the mains. For pump 1, pump 2 are displayed indicating the suction and the discharge pressure at both the pumps and the outlet, and an energy meter which tells you about how much power each pump when operating in series or in parallel or in single, how much power it is taking. So if you go to the item consists of a sump tank. This is a cylindrical acrylic tank which consists of the water. This is our storage tank. The pump takes the water from the storage tank and the water goes back to the storage tank. So this is a recirculating unit. So if you see at the suction of the each pump and the discharge side of the each pump, we have given pressure sensors which tells you about how much pressure it is taking while the suction and the discharge. With the help of these boards, you can make the unit either in series or in parallel or in single pole. So first of all, when we are operating, we will operate this apparatus in series mode. For operating this item in series mode, make this suction valve open. Close the suction valve of the pump 2. After this, close this valve also, so that the water goes from this side. Then this water of this pump is taken by the second pump, and then the overall charge will be gone from the discharge side. Now start pump 1 and simultaneously pump 2. As you can see, the suction pressure on the pump 1 is 0.4 and the discharge pressure is also 0.4. With the help of this F1, we will go to the next screen. The suction pressure at the pump 2 is 0.1 and the discharge pressure is 0.9. If you go to the main screen, the discharge pressure is 0.8. Now to draw the characteristics, the flow rate, we will get the flow rate is 168 lph. So to draw the characteristics, we will draw at different flow rate. So we will operate the different flow rate. As you can see, the flow rate is decreased and the suction discharge pressure is increased. So we will go for the different flow rates and the different discharge pressures. So we will note for up to 0. Now we will operate this unit as a parallel. For making this unit parallel, both the suction valve should be open and this valve should be closed. And this valve should be open. So now the unit is operating in a parallel. Both the suction valves are open, this valve is closed and this valve is open. So this is also taking the water, this is also taking the water, and the flow rates of both the pumps are summed up here. Again, the same procedure, we will go to the first screen which tells you the suction pressure and the discharge pressure of the first pump, suction pressure and the discharge pressure of the second pump, and it will show you the main discharge and the flow rate. Again, we will change the flow rate and see what happened to the discharge pressure. Now, if we are operating, now we will operate it as a single unit. So I will switch on one pump and will make it so that it operates only single. So you can see the suction pressure we have on the pump number 2. The discharge is 0.7, main discharge 0.7, and then the similar. I will close the valve for changing the flow rate and we'll see what happened at different flow rates. So we will draw the characteristics and try to deduce a relationship between what happens to the main discharge at a particular flow rate when the pumps operate in a single unit, when the pumps operate in series, when the pumps operate in parallel. Similarly, with the help of this energy meter, with the help of this scrolling button, we can go to the different options and see how much power it is taking. You can see, I can scroll and see it is now taking as 0.316 kilowatt. The voltage taking is 236. The current it is taking is 0.95. Power factor is 0.95. Sorry. It is the frequency, and here we are getting the power it is taking. It's 0.317 kilowatt. Okay. As you can see, if I operate this in parallel mode, the current has been increased to double. The power it is taking 0.343, and when it is operating in series, so as we can see, when this unit is operating in series, it is taking more power as compared when it is operating in parallel or as a single unit. Thank you.